Hi, Pre-Calc. We are in the vectors unit, and since the only problem that we've done like this in class was actually not like this, okay? It was like this, same idea, same type of problem, but the directions were not given in the same format. Because of that, I wanted to make sure you'd seen the one where the directions were given in this format, which is very often the format you used in physics when you were talking about vectors, if you have taken that. So that might be helpful to you. Basically, this whole north, then an angle, and then east, it basically comes from this idea. You start out, first word is always north or south. And so it's basically telling you it's basically going up or it's basically going down. And then, so anything that's pointing at all up is going to start with the letter N. Anything that's pointing at all down is going to start with the letter S. So let's say I had one that was right here. Okay? Because it's pointing down, I would start with the letter S. And then I would talk about, basically, since it's not going due south, how far to the left of that or to the right of that I'm actually going. But we don't think of it in terms of left and right. We think of it in terms of west and east. So yes, it's starting to go south. It's starting out in terms of going down, but we're actually moving to the east from that. So whatever this angle is, goes here. Let's say that's 40 degrees. So south 40 degrees east is how this would be described. Or let's say it looked like this. Okay, now this definitely looks like it's more going to the left than north, but we always start with north or south. So we basically first start out by thinking, is this basically going up or basically going down? Is it heading above the x-axis or below? It's going up, so we will start out with N for north, and then we need to say how far off course from north it's going. Because if it was going due north, we'd just say north. But it's going to the west of north. So I'm going to say however many degrees this is to the west. So like if this was a 70-degree angle, I would say north 70 degrees west. Okay, so in that with that respect, or with respect to that, or whatever it is I'm exactly trying to say, let's go back to the problem at hand. Here it is. The Goodyear blimp pilot has charted a course with a bearing of north 35 degrees east at an airspeed of 75 miles an hour. The blimp is actually moving 68 miles an hour in a bearing of north 70 degrees east. What is the velocity of the wind? Give your answer as a magnitude and as a direction. Okay, well the first thing is we've got two different types of speeds here. Sentence 1 here is telling me about the course that the pilot has charted. Think of it like if he had to put in what he was trying to do into the autopilot. Okay, he wants to go this fast and in this direction. Okay, so that's his intended. That's one way you can think of that, his intended or his projected speed. You could also think of it as the speed relative to the air around him. Okay, so we're going to call that his projected or his airspeed. The problem is he's not going to actually go in that exact direction and at that exact speed because he's being blown off course. And the wind that's blowing him off course is changing his speed. So that's what the second sentence is doing. It's telling me what is actually happening. So this is his actual, or what's going on with respect to the ground. So in other words, he's actually moving over some cities in a different direction than the ones he would be moving over. So with respect to the ground, this is what's actually happening. We want to know what's going on with that wind that is pushing us from our projection, our expected course, to our actual course. Okay, so the first sentence, and I just sort of made a little description of this. First sentence, from the pilot's perspective, that's going to be your airspeed, or you could also call it the projected. The second sentence is actually moving, that's your ground speed. Now the relationship you need to know about these things is your intended, this is your projected or your intended speed, plus the wind gives you your actual. So that's the relationship you have to understand, and you have to remember that. That your airspeed or your projected speed, your intended speed, plus whatever the wind is doing to you, gives you the actual or the ground speed. Another way you could look at this is, if I'm trying to solve this for wind, if I want to find wind, let's think of solving this equation for wind, I could subtract this from both sides, and the wind is going to be the ground speed minus the airspeed. So again, the second sentence was ground speed. The first sentence was about the airspeed. I'm going to have to take both of those sentences and write them as vectors and then subtract. I'll subtract ground speed minus airspeed. So let's look at the ground speed. The ground speed, we take the speed that we're moving, that's my magnitude. So 68, and then I'm going to have to say cosine of some direction, and 68 sine of some direction. This is how I'm going to describe my ground speed as a vector. Okay, projected or the airspeed, magnitude of 75 cosine some direction, 75 sine some direction. And I'm going to subtract. The problem is I have to figure out the direction, because this is not how we describe directions when we're doing cosine and sine and stuff. We describe directions from the standpoint of over here is 0, and we go, it's called a rotational angle. We rotate around counterclockwise. So that's the kind of directions I have to put in here, and that's not the kind of directions I was given. All right, so I have to compare and figure out how to transfer from this type to this type. Basically, kind of like the angles we use when we're talking unit circle. So first of all, let's look at this first one. North, 35 degrees east. So that means it's going basically upward. But if it were going north, directly north, it's being blown off course 35 directions toward the east. Excuse me, not 35 directions, 35 degrees toward the east, which is to the right. So this is going, and I'm not worrying about the magnitude here. This is north 35 degrees east, because it's 35 degrees to the east from north. So starting out north and then moved 35 degrees to the east. Okay, so in terms of my rotational angle, the first quadrant is 90 degrees here. So if it's 35 degrees from being straight up, this is going to be 90 minus 35, which is 55. So my directional angle for the very first one, which was the airspeed, is going to be 55 degrees. Then the second one was north, let me give it another piece of paper here, north 70 degrees east. So north 70 degrees to the east of that. Here's east over here. But when we want to think of that in terms of this being 0 degrees and rotating this way, well, that means I'm going 70 degrees less than 90 degrees. So my theta here would be 90 minus 70, which is 20. So this is going to be 20. Now that I have angles and magnitude and everything filled in so that I have expressions for both of those vectors, I'm going to want to subtract them, but I might as well just go ahead and change them to decimals first. That's going to make life a little easier. So for the first one, 68, let me make sure I'm in degrees because we're using degrees. So 68 cosine 20 gives me 63 point, let's go with tenths. 68 sine 20 gives me 23.3. And this one, 75 cosine 55, gives me 43.01. And 75 sine 55 gives me 61.2. 38.4. So here's the vector that describes the ground speed. Here's the vector that describes the airspeed. And we already said that to find our wind, the vector for wind, we're going to subtract ground speed minus airspeed. So I just have to subtract this vector minus this vector, and that'll give me the wind vector. So wind is ground speed, same thing as actual speed, minus projected or airspeed. And this is going to give me 20.9 and 23.3 minus 61.4 gives me negative 38.1. So that's the vector, but that's not what I was asked for. I was actually asked for give my answer as a magnitude and a direction. So basically, I have to find the magnitude and direction of this vector. Remember, for magnitude, that's kind of like Pythagorean theorem. The magnitude of the wind is going to be the square root of 20.9 squared plus negative 38.1 squared. So 20.9 squared plus negative 38.1 squared gives me 1,888.42. And when I take the square root of that, I get 43. Let's go with 5. Now, magnitude in this context, remember, was the speed of the wind. So that's 43.5 miles per hour. Now, the direction, if this is going, this is my x and this is my y. This is my horizontal direction. This is my vertical direction. So I'm going left. I don't know why I did that just now. Okay. I'm not going left. I'm going right. If x is positive, we're going right. And I'm going to have to come up with a different piece of paper for this. So let me do that. I'm going right 20.9. And down 38.1. So I'm going to find this angle. I'm going to call it alpha. And remember, this is opposite and adjacent. And I'm actually not going to treat this as a negative because I'm just trying to, I'm thinking of it as a right triangle. Just think of this as a length for right now. And lengths are not negative. So tan of alpha equals 38.1 over 20.9. So inverse tan of 38.1 divided by 20.9 gives me 61.25. Let's go with 61.3 degrees. Okay. But when we say direction, we're not talking about the angle with the x-axis. We're actually talking about direction overall, like all the way around. In other words, this is just telling me, here's my vector. This is telling me this angle. You can't see it. There it is. So that angle is 61.3. I want to know, starting here, how far I have to rotate to get there, my direction. So I'm going to subtract, since this is in the fourth quadrant, 61.3 less than 360 is what I've got. And I get 297.8. I'm sorry, 298.7 as my degrees. And that is my answer.